It's time to learn about cylinders. So I have this little cylinder here. I covered it with paper because I want to teach you about surface area first. And whenever we cover something, we're talking about surface area. So I had to cover the top and the bottom. It's a cylinder, so the top and the bottom were both circles. And then around the curvy part, which we do call the lateral part of the cylinder, it's almost like a soup label if you've ever taken the soup label off of a can. You get just a big old rectangle. And so the surface area of a cylinder is going to be the area of the two circles added together plus a big old rectangle. So let's see what that looks like in terms of a formula. So let's go to this sheet. I see a lot of similarities between cylinders and prisms because they both have their congruent bases, if you want to color both of them in. They have circles on the top, circles on the bottom. And we said yesterday that the lateral faces were rectangles for a prism. Well, the lateral face is kind of a rectangle, even though it's bent around. So they do have a lot of similarities, these two. So the formulas that we're going to use, and I put this in a different order than some people, but surface area goes like this. 2 pi r h plus 2 pi r squared. And I remember this because some kid in my 8th grade class said 2 pi's are happy plus 2 pi's are squared, and for some reason, years and years later, I still remember that. I was wondering if you could tell me which part of this am I going to highlight in orange, or which part of this stands for the area of the two circles. And I'm hoping, if you know the area of a circle formula, that's the pi r squared, right? And so those two orange circles that I colored in, that's this part. That's where that 2 came from, because there are 2 pi r squareds, the top one and the bottom one. And so then I bet you can guess what this 2 pi r is. That's the wraparound rectangle, so that is the lateral area. I can't really say that it's lateral faces because it's not so flat when you wrap it around, but definitely the side is still considered to be the lateral area. We might as well fill in volume while we're at it, and it's just like the area of the base shape times the height, only in this case the area of the base shape is pi r squared times height. It's that easy, so it just like a prism, you get that base area in there, the pi r squared. You fill up the bottom of the pool, and then you fill it up to the top with the height. And so that would be our formulas that we need today. Here's all that lovely information written out. Our cylinder is a solid with 2 parallel circles as bases. The lateral surface area is the area of the curved side part of the cylinder, not including the bases. I kind of like this diagram over here where it shows the 2 circles that are pi r squareds. Maybe you figured out right here the circumference has to wrap around our circle, right? So circumference is 2 pi r. Then if you take that times the height over here, that's where that 2 pi r h came from. So, and then we had our other formula. Let's just try a couple of problems. So here's a cylindrical building. It can happen. Here's what we know. It's the University of Crete. The architect needs to make the building 50 feet across and 20 feet tall. What amount of building materials does she need to create the base, the sides, and the roof? And so if we're just creating the base, the sides, and the roof, that doesn't mean that we're filling it with anything. So if we're building something and not filling it, we're going to be talking about the surface area. So our surface area formula, 2 pi's are happy plus 2 pi's are squared. 2 pi radius. The radius is 25. Tricky, because they told me the width was 50. That's technically the diameter. The height of the building is 20. So my radius again is 25. This formula is just so easy to use. As long as you can figure out the radius and the height, you just plug those in. Now there's one new thing that I want to teach you, and this is saving the pi till later. Okay, so in your calculator, if you could just type in the 2, the 25, and the 20 multiplied together, I got 1,000. So we could take 1,000 times pi, but let's just leave it like that for now. So that's the 2, the 25, and the 20. We still should have a pi there, but we're saving it till later. And then over here, I'm going to take my 2 times my 25 squared first. It just saves you from having to deal with decimals right away. So we'll just do like the nice number stuff first, and we'll save the pi for later. Now if you have 1,000 pi's, and you add on 1,250 pi's, how many pi's do you have? 2,250 pi's. Sometimes you'll see people leave that as their answer. They say that that's an answer in terms of pi. That's not super useful to the people that you're buying your building materials from. So now it probably is a good idea to type in 2,250 times pi button on your calculator. This will be a more useful number when you go to order your supplies. So I got about 7,068.6 square feet of building materials to build that building. So this isn't an exact number. In terms of pi, it's still exact. I didn't have to round anything until I put that pi in there. One volume problem. How can I tell this is a volume problem? Because we're filling it up. It's a swimming pool. How much water does the pool hold? And so we're going to be using our volume formula this time. Area of the base shape times the height, pi r squared h. This one is 24 feet across and 52 inches deep. Did you catch on that they're using different units here? So 24 feet across, 52 units deep. Maybe we should do a little conversion first. So do you want to go all in inches or all in feet? My first instinct would just be to go all in inches because that seems easier, but later they're about to ask me something about cubic feet, so maybe I should try to put this 52 inches into feet instead. So how many 12-inch chunks are in 52? Turns out to be 4 1/3, or 4.3 repeating feet. I think I'm going to use that for my height. Then I'll have everything in terms of feet. Here we go. Volume, pi. Radius, don't be tricked, that was 24 all the way across, so our radius is only 12. And our height is 4.3 repeating, or 4 1/3. I'm going to do that in terms of pi to start out. That means I'm going to ignore the pi for now and just do the 12 squared. 12 squared times, now if you're typing in 4.3333333, type a bunch of 3's, okay? And if you type a bunch of 3's, you should get 624. Pi hasn't been included yet, so that is still in terms of pi. Now we're going to be forced to round it because if you're filling up your pool, you probably don't want to have your answer in terms of pi. So here's an estimate for how much that is. 1,960.4, and that's in cubic feet. I tell you what, that number would have been a lot huger if we were talking inches, so I'm glad we changed it to feet. If a cubic foot is 7.5 gallons, which I have a hard time, I've thought about this a lot. Can you picture a cube that's 1 foot by 1 foot by 1 foot? Turns out it can hold 7.5 gallons if you think of your gallon jug of milk. It still blows my mind, but how many gallons could I fit in a pool that's 1,960 cubic feet, sorry. Well, it's going to be a lot because each one of those has 7.5 gallons. So I'm actually going to take that number times 7.5. It's insane. 1960.4 times 7.5. It's a whole heck of a lot of gallons. Oops, and now we're in gallons. You can see why it might get a little expensive to fill your pool each year, because that's a lot of gallons. The only other thing, and maybe we don't need to do an example, but I might ask you just for certain parts of your cylinder. For this one, I'm asking you to cover it with paper. Keyword cover. Is that surface area or volume? Surface area. Fill means volume, so covering is surface area. 2 pi RH plus 2 pi R squared. And here's the fine print. I want you to cover just the sides of the can. So how would we not include the top and the bottom circle? It's actually pretty easy. We would just ditch the 2 pi R squareds, because remember, pi R squared is a circle, and we don't need, if we're just doing the sides, we don't need either of those. So then you would only have to put in your numbers into that part of the formula. And then if they ask you later how much more paper if you want to decorate the top, remember the top is just a circle. So you would just use pi R squared to get the top. You wouldn't need the 2 pi R squared because nobody said we wanted to cover the bottom. But I just wanted to show you one of those in case I ask you just for parts of your cylinder.